So tonight I was imaging some things. I set up a plan. This is the plan I'm executing. I am imaging M81 and then NGC 891 and then M45. So I'm going to image three objects throughout the night. And when I was in the app and I was just looking at the stargazing and I'm watching it appear in the app as it materializes. There was something in here that I've seen this before, but never really paid attention that it existed. And up there in the top, right next where it says M81, there's a little information icon. And I've never really clicked on those before. And so if you want to learn about the objects, maybe I'm just slow to the party, but I clicked on that information thing and I can read all about Bode's galaxy or M81, the one that I'm imaging now. In addition to that, if I scroll down further, I can see its visibility in the night sky. I was able to see this visibility when I created the plan, but here's another way that I can see its trajectory through the night sky. I can move that little dial thing to different times of the night too, and figure out when it's up at what point in the night. And so that can be helpful as you make your plans. Um, Another thing that is in here are the coordinates. And I thought this might be a good time to cover what these coordinates are. There's a whole bunch of little um, abbreviations of things here, and I thought maybe we would cover a little bit of what these are. The very first one in that list is RA, and then right below it is DEC, and then ALT, and then AZ. So the RA and the DEC, they are celestial coordinates. They're similar to Earth's longitude and latitude, and they're fixed to the stars, while ALT and AZ are local observer-based coordinates that describe an object's height above the horizon, like the altitude and its direction along that horizon from the north, which is the azimuth. RA is measured in hours from the vernal equinox, and DEC is measured in degrees north or south of the celestial equator, while ALT ranges from 0 degrees to 90 degrees above the horizon, and AZ ranges from 0 degrees to 360 degrees clockwise from the north. So the RA, what it stands for is right ascension. It's the astronomical equivalent of longitude on Earth, and it's measured along the celestial equator and the projection of Earth's equator onto the sky. Typically, it's measured in hours, minutes, and seconds of time. There are 24 hours in the full celestial sphere, with 1 hour of RA corresponding to 15 degrees of arc. And its reference point is measured eastward from the vernal equinox, the point where the sun crosses the celestial equator in March. Now, the DEC is the declination, and it's the astronomical equivalent of latitude on Earth. It's measured north or south of the celestial equator, and it's measured in degrees, just like the latitude. The reference point is 0 degrees, DEC, is the celestial equator, and a plus 90 degrees is the north celestial pole, and the negative 90 degrees is the south celestial pole. ALT is the altitude, and it's an observer specified measurement of how high an object appears in the sky, and it's measured as an angle above the horizon, and its units are described in degrees. Its reference point is an object on the horizon is at 0 degrees altitude, and the zenith, or directly overhead, is at a plus 90 degrees. The AZ, or the azimuth, is an observer-specified measurement of the object's compass direction along the horizon, and it's measured in degrees clockwise from due north, and it's measured in degrees. As reference point, 0 degrees AZ is north, 90 degrees AZ is east, and 180 degrees AZ is south, and 270 degrees AZ is west in encircling the planet. And so those are some of what those coordinates mean and how they are described, and we can use those um, coordinates in other functions in the app. But I just wanted to show you that those were there because, we play around on the app and sometimes we just see what we see and we just ignore other things that we aren't using. But I thought that was interesting that those are there. And so if you want to get some educational information about objects that you're imaging, just click that little eye up there when you're doing the stargazing. So again, to get there, you're on this home page of the app. You click on the stargazing, and then up along the top is that M81 telling you what you're imaging currently. And you see I've been doing this for almost an hour, and so it's starting to appear pretty nice. But if I want information about Bode's galaxy, I can just click that eye and it will give me information, and that's kind of fun and educational. It would be really nice too if you're showing other people how the app works and some of the objects you're viewing, just to have some things to read because just sitting there staring at the screen as it materializes, it can get a little redundant, especially when you're doing 10-second exposures and not a whole lot changes in 10 seconds. You can use that time to learn about the objects, because we want to learn what causes them. The scientists in us want to know more about the objects and what created them and what makes them appear the way they do. So we can get that information there. I just wanted to point that out and share my little revelation to myself about what's in the app and the capabilities in there. Anyway, we're wishing clear skies to everybody. Thanks for watching.